Hi there, everyone. Let the more and more people join in. We are already live now, and we will be seeing some special examples related to today's topic that I had as told you, and some mixed kind of questions. So welcome. So those of you at live, just hit hi or something. At least I can interact with you. The main purpose of my live lecture is that I don't have to do too much of recording and editing and all that stuff, and we can interact with each other as much as possible. You can uh, you know type your doubts in chat or something, just to hold a live class, so that and I had got few feedback from of some of my users and some of my students that they want to see me on the camera, like what is who's the person teaching they wanted to see. So I said, okay, let's go live. That would be a good option. But as far as, according to me, as far as a good content is delivered to you to understand mathematics, I think seeing the person won't matter. But anyways, um, let us see. Let a few more people join in, and we can just hi, hello to all of you, those who are there online. I like hi, hello. I know it is some some of them are on other part of the globe, maybe you know so for them it might be day, some of them it is night, some are tired out of their work and study and everything, and still they are here. Welcome to all of you, kudos for joining in. So I'll hold on for a few minutes and then we will start. I hope when you did this eigenvalue eigenvector topic with me, you understood the nuances. Okay, my whole aim of this, yeah, hi, hello, my whole aim of this online lecture is that maximum people benefit out of it. Okay, otherwise I don't know, like and the best part of going live, I would say, is a lot of editing work is reduced at my end. I can be free, and I can deliver what is crucial, and you can also relate it to what is happening and how it is happening. You can see me solving, and you can see me working over there, rather than giving a scripted video lecture. Okay, let's start now. Let people join in. Let more and more, you can share it with your friends for more and more people to join in. So we will start with this, and we will begin with some important points. Now, as I had told you, today's lecture that I am going to discuss are, as you had seen the thumbnail, that it is what it you can call is, this is a special video, a special kind of questions we are going to see on eigenvectors. But then I also want to tell one very important thing here, that along with special questions there are special cases that I am going to see. Okay, special cases. Now so we have over here, what do we have is one important thing. Just by seeing a different matrix, you won't get to know what kind of eigenvalue a matrix is having. Okay, sometimes it is easy to guess. Okay, just by observation, or just by observation, it is not always possible to find eigenvalue. Okay, as they the eigenvalues are hidden, the session will be maximum of 1 hour or maybe 1 hour 30 minutes, not more. Okay, the session will be max of 1 hour, max 1.30 minutes, 1 hour 30 minutes. I'm not gonna stretch this a lot because I want to deal I want to keep it crisp, I want to keep it to the point, and I'm not going to deviate too much from the topic. I'll just speak main part and do the main kind of questions that have been seen most of the time. Okay, just by observation, what I wanted to say with matrices, I would reiterate it. Just by observation, it is not always possible to find eigenvalue, although there are cases where you can conclude some things regarding with observation, unless a matrix is a very special kind of. Okay, it depends upon the matrix. Second, it depends on the type of matrix that is given. Type of matrix, what kind of eigenvalues we will have. Okay, that is one thing. It depends on the type of matrix. Maybe a matrix is general, it is neither symmetric nor then there is no problem, you just solve as per the procedure. But if it is symmetric and all entries are real, then you are bound to have real eigenvalues and then all the other properties and all that. Now one thing, let's see, eigenvalues can be real numbers or they can be complex numbers. Please remember this. They can be either of them. There is no boundary on them. Okay, they are not restricted. In mathematics, there is something called field, so that is they come from field, but it is okay, we will not bother about it much. Now one more thing I wanted to tell you regarding them. Let us see, there are few properties and I would like to deal here. So first important property is there: if a matrix A n cross n is an triangular matrix, then its eigenvalues are its diagonal entries. Okay, this is one very important thing. So for example, now this is where I wanted to deal, that you just see the matrix and directly you can write. These are, I told you that in this topic maximum number of MCQs can be formulated. So when maximum MCQs, there are very high chances, like if you give any competitive examination, the questions will be based upon the type of the eigenvalues and the properties of the matrices and their other interactive properties and all. So this kind of questions are always there. So this is just by observation, you can clearly say. Now as I told you, it is not always possible, but in some cases it is possible. So here if I have a matrix, let's say -2 0 3 6 0 8 0 0 0, if this is the matrix, okay, then here eigenvalues are immediately, because this is an upper triangular matrix. Okay, since A is upper triangular, you can directly claim that therefore eigenvalues are lambda 1 equal to minus 2, lambda 2 equal to 6, and lambda 3 equal to 8. Direct. No need to even solve, otherwise even if you do that standard procedure, you are going to get lambda equal to 2, 6 and 8. But this is one time saving thing that I have, it always works out. Similarly, if you have another matrix, let's say B, let us take up, let's say 3, 7 and minus 1. If you have, and here it is 2, 4, 5, and here there are 0, 0. Again, since A is lower triangular, we can directly write this here. Eigenvalues are one is 3, lambda 2 is 7, and lambda 3 is minus 1. Sorry. This is what you can straightforward say. Now there is one important property I wanted to give you. It's a shortcut method to find an eigenvalue. Let's say this is one very popular question, like I just had done with few of my students. Then I wanted to tell you also that let's say without solving, we can say in this case, without solving, determine at least one eigenvalue of, let's say, A equal to 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, now this is the matrix which is given to us, and determine at least one eigenvalue they are asking. So I'll tell you a shortcut over here again. So what is one shortcut here? That is, first thing, you need to know this property. It says that since the property is there that matrix A has two rows equal. I'll just talk about two rows. Any two rows you see, they are equal, right? All the three rows are equal. It implies determinant of A is 0. Okay, now determinant of A is equals to 0. We also know that determinant A is nothing but we have here determinant A is product of eigenvalues, right? So it will have lambda 1, lambda 2, lambda 3 as the product, and now we have already claimed that this is equal to 0. Lambda 1, lambda 2 and lambda 3, determinant of A is 0. It implies that at least one eigenvalue will be 0, right? So one of the eigenvalue, so at least one lambda is 0. So let's say lambda 1 equals to 0. Okay, we have got one eigenvalue. Now another property here is that, now this is again from the properties of the determinant and the matrices and all. Like, I'll give you a shortcut now. So what is the shortcut? Let me write the shortcut here. Shortcut formulas. shortcut. What is the shortcut? Just if you have an MCQ, okay, don't try to do these things in examination. I strongly tell you that these is all techniques are used for competitive examinations, and if you have a descriptive answer style, then it is fine, you can do. But if you have an MCQ or a quiz or a competitive examination, or you are in a press of time to get it done fast, that time you can do this. So another shortcut technique is there. How to find the eigenvalue? So total of every row must be same. Total of every row must be same. Then total of every row must be same for A. Then that total is an eigenvalue. Okay, and you can also say here total of every row I have told, or here you can also add one thing, or column. If you have this, you can write this in bracket. So then that total is an eigenvalue. So now in this case what you can see is we have 1, 2 and 3. 1, 2 and 3 is the row. So if you add up 1 plus 2 plus 3, that will give you 6. So total is 6. Here also total is 6. Here also total is 6. So the total, this 6 also, hence by the second method you have lambda 2 is 6. Okay, you have got lambda 2 also over here. So lambda 2 is 6. And what about column? Let us see column also. So column, here it is 3, here it is 6, and here it is 9. So this is not working. You leave it, but for row it is working, right? So you leave this column right now for time being, it is okay. Here it is 6. So lambda 2 is 6. Now if you want to find the third eigenvalue, then you can say lambda 1 plus lambda 2 plus lambda 3, the trace. Do you remember? It is the trace. So trace is over here is 6, right? So you have already found one value as 0, other value lambda 2 you have already found 6. So if you want to find lambda 3, then you do the algebra, you write this is the trace A. So if you do this, lambda 3 is equals to 0. So you can now also see that 0 is repeated 2 times and lambda 2 is 6 is 1 time that it is repeated. So such kind of thing you can do. Oh, just a minute, I think you are not able to see because of the camera there. I'll just adjust it a bit. Okay, yeah. So here you can observe the thing. Yeah, so you will get to see this, that this is how you calculate, because we now know that 2 eigenvalues we got. There are obviously going to be 3 eigenvalue because of 3 cross 3 matrix, and then you have the property lambda 1 plus lambda 2 plus lambda 3 is 6. So you go for 0 and 6 as lambda 1 and 2, you get lambda 3 as the total. When you want to take up, then you get 0 as the answer, right? So this is one easy way out also, but it doesn't work all the time. Okay, you have to check every row total should match, and it should come to be 6. Suppose other one of the row is 5, it won't work. this was one example that I wanted to deal. So you can try this also. So there were some examples, uh, some students had this with them. There is 4 1 1, and then 1 4 1, and there it is 1 1 4. If you take this matrix, then one eigenvalue can be immediately told even without doing the calculation of the formula and all. So one eigenvalue is lambda 1. I can say clearly it is 6, because what is happening here is the row total is 6. Okay, so row total I got 6. Okay, now see, column total is 6, here also it is 6, so it doesn't mean the second eigenvalue is 6 right now. You don't take it for granted like that way, but 6 is one of the eigenvalue. I cannot tell you whether it is repeated. You have to be very careful regarding that, whether it is repeated or not. Otherwise you can make mistake in that case, whether it is going to be repeated or not. So you have to be very careful for that. Now, so this is one thing I wanted to deal. One more now important topic. So these are, so shortcut I gave you. So what is a shortcut, hip hip hooray kind of thing, what you can call, is that I gave you that shortcut saying that total of all eigenvalue, total of the for finding the eigenvalue, total of every row or the column must be same for A, then that total is an eigenvalue, okay. Be very careful with that. So this is one shortcut that helps you to find your answer. Now let me take you to the next kind of question, and a very important thing. This was asked in one of the examinations for 6 marks, and the funniest aspect of this is people did not realize the difficulty in it. The like, see, just by looking at the matrix, as I told you, you cannot do the solving, or you cannot just by something, whatever things are available you can get it, but then you don't know how does it behave also. So find the eigenvalues. I wanted to do this question, an eigenvector vectors for A equal to 4 1 minus 1, 6 3 minus 5 minus 2, 2 and 6 over here. Okay, these are the values in the matrix. So let us calculate quickly. Can you tell me what will happen for the eigenvalues? So we will write here ax equals to lambda x. X is not equals to 0, therefore determinant a minus lambda I equals to 0. So we now write down that characteristic equation. So characteristic equation is lambda cube minus the trace, so 4 plus 3 is 7, 7 minus 2 is 5, so 5 lambda square, and then the m11 is obtained by deleting the first row and the first column. So it is, yeah, can you tell me what is m11? If anybody is calculating over there on the other end, could you tell me what is m11 and the determinant? I would be glad. If you can tell me, then I would be very happy. Just type your answer in the chat box. M11, you delete the first row and the first column, so you will get minus 6 plus 10, so it is 4. What about M22? M22, you will delete the second row and the second column, so it is minus 8 plus 6, and here it is, yeah, 4 is regarding M11. Is it M11? I'll continue. Then yeah, minus 2, and M33 goes at 12 minus 6, it's 6. Yeah, so here you have, yeah. What about determinant? Could you please tell me what is the determinant of this matrix? Wow, we have someone there. Hi, hello to all those who are joining right now. This is a very special matrix, and there was a twist in this and many children went wrong, so I just don't want anybody to go wrong further. That's why this I'm taking. What is the determinant? Could you please tell me? Determinant, is it 6? Determinant answer, I'm waiting for your answer. Is it 6 or something else? Four is the determinant. That's what I have got the answer on the chat. Okay, 4 equals to 0. So can you simplify this, and can you check your eigenvalues which come here? So yeah, 4 is the determinant, and so 10 and 2, 10 minus 2 is 8, lambda minus 4 equals to 0. Can you check what are the eigenvalues coming? I guess 1 2 2 or 1 minus something. What is it? What are the eigenvalues coming? Can you tell me the eigenvalues? You need to do some synthetic division, something. What are the eigenvalues? Yeah, 1 2 2. So eigenvalues this is the what our famous characteristic equation, and eigenvalues lambda 1 are, lambda 1 is 1, lambda 2 is 2, and lambda 3 is also 2. So yeah, so those of you are familiar with algebraic multiplicity. Algebraic multiplicity means the number of times an eigenvalue is repeated. So algebraic multiplicity of lambda 1 equal to 1 is 1, and so in short we write am of lambda 2 equal to 2 is 2. Okay, now in this case what happens is very important, and this is where people made mistake, and we will be first finding the eigenvector for lambda 2. Okay, lambda 1 you can do it straightforward, you can use Kramer's rule, not a big problem. Okay, it's not a big problem. I'm going to do for lambda 2. Okay, you can use Kramer's rule and get that. We will do, let's see, I'll do for lambda 2 first. Now so for lambda 2 equal to 2, what happens there? Can we have this? So a minus lambda 2I times capital X is equals to O, and then this happens to be the matrix. So we have to subtract 2 from the diagonal, right? So it is 2 6 6, and then there is 1 1 2, and here there is, how much is it? -1, -5 and -4, right? This is what we have to get. So this is x1, this is x2, this is x3. So this is 0, 0, 0. Right? This is how the whole thing you write. Now I have strongly told everyone that whenever eigenvalues are repeated, I have clearly made an instruction that do not use Cramer's rule. You must follow row echelon form method to find the eigenvector. So we will make it row echelon and check how it works. So first we perform R1 interchange with R2. So we have here 1, 1, 2, and here there is 2, 6, 6, -1, -5 and -4, x1, x2, x3, and then there is 0, 0, 0. This is what we have. After this we perform, we want to make these two numbers 0, this one and this one. I want to make it 0 by using row transformation. So I perform R2 changing to R2 minus 2 R1 and R3 changing to R3 plus R1. Okay, this is what is there. And so now when I try to do that, what do I get? I get 1, 1, 2, the one which are already there. Okay, yeah, the first row remains same. What happens in the second row? In the second row I get 0, here it is 4, and here it is 4. No, not 4, here it is 2. Here there is 2, and here I'll get 0, and addition, right? Again there is minus of 4, and then there is minus of 2. This is x1, x2, x3. Okay, this is what we get. Are you all comfortable so far? Let me know, and that will help me to gauge that yeah, it is fine, it is working good at your end. So how is it fine, working so far so good? Let me know there, because now we are going ahead. Yes, all good? Yeah, fine. So what is going to work now? We reduce the third row also. So basically I will be now performing R3 changing to R3 plus R2. Okay, yeah, so I get 1, 1, 2, 0, 4 and 2, 0 and 0, 0. This is what I get. x1, x2, x3 and 0, 0, 0. Now remember here, what is the rank over here? This is the rank. So rank of a minus 2i. Okay, a minus 2i. What do I get? A minus 2i is the matrix. Okay, a minus lambda 2. This 2 is the lambda 2. So what is the rank of this matrix that we see here in the row echelon form? Non-zero number rows are 2. So this rank is 2. Number of unknowns. Number of unknowns is 3. So the GM of lambda 2 equal to 2 is given by the formula n minus r. The rank that we found is r. So it is 3 minus 2, which is 1. This means that, yeah, oh wow, thanks. It's good to have you, Nikunj, here. After a long time, right? Maybe after a year back. Great. So what do we have is very crucial. This question was in one of the examinations in other branch, and many people goofed up over there. So this you have to be very careful. Lambda 2, algebraic multiplicity is 2, that means it is repeated 2 times, and geometric multiplicity is 1. So first conclusion here, you can have am of lambda 2, which is 2, is 2, this number 2, and gm of lambda 2, 2, I would always suggest write like this in the bracket, because lambda 2 equal to 2, the moment I say it is the number which comes into the mind, but no, it's not so. So it is 1. So these two are not equal, right? 2, this is 2 and this is 1. That's why what is going to happen, matrix is not diagonalizable at this stage. Okay, obviously it is not diagonalizable. Yeah. How many eigenvectors generates, that way we can also find a GM. Now sir, what for particular eigenvalue, how many eigenvectors are generates, that way we can also find GM. It is not see that particular eigenvalue generate. What do you mean by generate? Can you tell me what do you mean by generates? Generating means what? It means it produces. How does it produces? Like, is there a formula? You need some formula, right? Otherwise if you do Kramer's rule, you will go on getting the answer. It's not that way. You need to have one stopping point, because lambda 2 is 2. So most of the people thought over here there are 2 eigenvectors going to come, because its algebraic multiplicity is 2, but geometric multiplicity is 1. So remember, you can have 2 eigenvectors for this eigenvalue if and only if am and gm match. Okay, you can have 2 different eigenvectors only and only, please note down, I'll give you here, we can have 2 eigenvectors for lambda 2 equal to 2 if and only if am of lambda 2 is same as gm of lambda 2, which is not the case. GM determines, remember that GM determines the number of eigenvectors that will come. That is the main principle. I hope you remember in your previous semesters you people have learned something called independent variables and free variables and all that. This is the time it comes into the picture. This is the place where it is very important. So here here we will have the system what we got. So we'll write the system. So we will have only one eigenvector for lambda 2 equal to 2 in this case. Okay, so what is that eigenvector? We will get here, see, x1 plus x2 plus 2x3 is equals to 0 we have got, and 4x2 plus 2x3 is equals to 0. So you solve this system of equation. Okay, when you solve this system of equation, you will get some answer, and that answer is important. Okay, So we just simplify this quickly and we'll get some answer right now. So what we can do is 4x2 is minus 2x3. It implies x3 is equals to minus of 2x2, and since x3 is this, so we will substitute in the above equation. So x1 plus x2 is plus 2 into minus 2x2 equals to 0. So x1 plus x2 minus 4x2 is equals to 0, which implies x1 is minus 3x2 equals to 0. So x1 is 3x2 and this x3 is this. Also remember, GM indicates the number of free variables. Okay, if you want somewhere, you can write down this at also remember that GM indicates number of free variables. Now I don't want to go into detail, you people don't have the concepts of kernel and null space and everything, but fine, for time being all this thing will work. Okay, so now when we go for writing the capital X eigenvector, capital X is x1, x2, x3. Okay, what do we get? We will be getting here, we now put the relations. So relations are x1 is 3x2, x2 is set free, and this is minus 2x2. Yeah, so this x2, when you pull out, you have the vector 3, 1, minus 2. This is the eigenvector that you have. Are you getting that? Okay, so you can put here, put x2 equal to 1, and therefore your x eigenvector, yeah, whatever you want to call x1 is 3, or x2 eigenvector, whatever, x2 3 minus 1 2. This is your eigenvector for lambda 2 equal to 2. You do not have, and you also mention there is no second eigenvector. There is no second eigenvector for lambda 2 equal to 2. For lambda 1, you can quickly do that. Lambda 1 equal to 1, you have a minus 1I into capital of X. So a minus 1I, what you get is 1 6, oh sorry, here you will get 3 6 6 1 2 2, right, and minus 1 minus 5, and then there is minus of 3. Okay, one more thing here again. Can you see that this eigenvector, when you want to do, okay, when you want to calculate the eigenvector in using Kramer's rule, we had decided that we must always take the first two rows. Okay, try to take the first two rows. Do you remember I had told you that you must take first two rows, but in this case you don't take first two rows. You check why. If you take first two rows, you will get all 0 0 zeros, right? You get all 0 0 zeros. In that is what you will be getting. So I suggest you, in this case, you can take second and third row. If you take first here x1, you'll get 6 2 6 2 minus x2 over something. Do you get all zeros? Yeah, you would, right? 3 1 6 2, all are zeros. x3 equals to then you have 3 1 6 2. So all these values become 0. So I suggest here, don't take the first two rows, because the first and the second row, can you see the first row is exactly triple the second row? Do you get that? Guys, those who are on the other end, do you understand that this one row, the row number 1, is double, or sorry, triple of the second row? By solving it shows infinite solution in Calci. What did you solve in Calci? Could you please tell me for what did you solve? Yeah, infinite solutions for the first eigenvector, are you saying? Eigenvectors are going to be plenty, but we need to find one main eigenvector, and this main eigenvector is the basis. There is a term called basis in mathematics. You don't have all this, but let it be. I don't want to get into those terminologies right now, but yeah. So there are many terms are there. We can uh, think about them later on. Right now my focus is regarding this matrix, which was a very special matrix. If you do Kramer's rule, you will land up into trouble. So for the first two rows, don't do takes you can take either second and third, that would work. So I would suggest you people taking second, third over here. Okay, let's take second and third one, so that should work nicely. So your eigenvector, rather in this case, you know what you should do? Basically, you should always, whenever such kind of things happen, you always go for row echelon method. Don't wait for any other method. Row echelon method is the most safest one. Anytime you will never go wrong in that method. Kramer's rule is what? It is a bypass, because there are students, those who don't know too many mathematical formulas, or some are new in the stream. So for them, Kramer's rule will work as an easy thing out. But for this one, you be little careful. So let's do here. So x1 is 2 minus 5 minus 3, then minus x2 divided by 1 minus 1, 2 and minus 3. So here we will not take the first and second, we will take second and the third one. So here you take x3 is equals to x3, you will get 1 minus 1 and 2 and minus 5. So x1 is how much? Minus 6 and plus 10, 4. Then minus x2, here it is minus 3 and minus 3 and minus plus 2. Okay, and here it is x3 is minus 5 plus 2. So x1 over 4, x2 over 1, right? Minus and minus will be cancelled, and here x3 over minus 3. So your eigenvector x1 is 4 1 minus 3. Okay, so there are only two eigenvectors for this solution. So here there are only two eigenvectors for A. Okay, for lambda 1 there is lambda 1 equal to 1, we have x1. Okay, we have x1, and for lambda 2 equal to 2 we have x2 and not third vector, not third eigenvector. This is extremely important example. This is what I wanted to deal with you guys. And there is now, let me take you quickly to another nice and a very tricky looking example, which was there in one of the examinations again for students, and students had really tough time seeing this. But I don't feel any student must have any difficulty in this question. At least the question again was very simple and very straightforward. Find the eigen values and eigenvectors for this matrix, and it also had something more with it. I'll do that also. Let us quickly do this. You must not feel difficult over here. I'll tell you how. Now you will see with this example. See this, 37 divided by 60. This was the value in the matrix. 17 by 60. 17 by 60. Wow. 1 by 5, all values were fractional. This was in one of the examinations and I was surprised, but it is a very nice question. 1 by 12. This is not in any of your standard books available, but it's a good question that is there. So 5 by 12. Wow, very nice question. Now the question after this was also show that the matrix A is diagonalizable and find its transforming matrix. Okay, and the diagonal form and etc., all that standard questions. Now when this question came, many students across various colleges and people were, tensed. Oh, why this thing and all. I feel you must not get scared at all. Why? Not because the matrix is difficult. Dude, you have calculator with you. Calculator is such a wonderful device. It can work miracles in examination with any difficult numbers. Why do you even have to get scared of the fractions? Calculator jindabad. You have calculator, so in any question you have calculator to show that it is going to work. Why do you even get scared of any kind of number coming? Let it be, calculator will do that, right? You don't have to put too much of brains behind it. Only thing is that in this question you remember, if such kind of things come in exam in future, if your answer comes and you see the nice way the matrix is given, you keep, if whatever answer comes, okay, hint over here is whatever answer yeah, means I personally don't understand why people were scared. People were calling each other, why, how this matrix has come, why this matrix. Are what is the difficulty? You got calculator, you do it. Calculator, I would say, even if 1000, 5000, 9000 are the entries inside the matrix, you need not get scared. You know the formula, you have the calci, you just have to plug up the values in the calcis. That was also paining to so many children. I don't understand then in which direction we are going to learn mathematics, right? And I means it's a very sad face then. Now for this question especially, what you need to do is whatever answer comes, you keep in fraction. keep it in fraction. That is the hint. That's it. Don't put it to decimals. इससे बस चलो, तो अभी ये क्वेश्चन करते हैं एंड आपको मज़ा आएगा ये क्वेश्चन करते हुए. चलिए तो हम करते हैं ये क्वेश्चन. सो our standard method, let ax equals to lambda x, x not equal to 0. So determinant a minus lambda I equals to 0. 37 by 60 minus lambda, 7 by 10 minus lambda, 5 by 12 minus lambda, and all other values as they are. Okay, you don't get scared on this, you keep them as they are. कैलकुलेटर बाबा हर जगह बचा लेते हैं, टेंशन ही नहीं. फॉर्मूला मालूम होना चाहिए, मज़ा ही मज़ा है. कैलकुलेटर में कुछ भी डालो सब दे देता है. कहाँ हमको वैदिक मैथ्स भी करना है इधर, हमको किसने इधर कुछ पूछा है. हमको तो खाली आंसर लाने से मतलब रहता है उस टाइम पे. तो इट इज़ वेरी इजी दैट इवन इफ़ यू आर गिवन अ हार्ड क्वेश्चन, आई डोंट थिंक सो कैलकुलेटर के सामने कुछ भी डिफ़िकल्ट रहेगा. इतना टेंशन लेने का ही नहीं है ये सब क्वेश्चंस में, आराम से सॉल्व होता है. फ्रैक्शन आ रहा है, आने दो, मज़ा करो. फ्रैक्शन को भी इज्जत देना पड़ता है ना. these numbers are there, you need to respect them, they are so nice numbers, they are so nice. And if you are not used to the number, that is our problem. But these are the numbers. So so what is the lambda cube minus trace? Can you use the calculator and tell me the trace? How much is the trace? I'll also do along with you guys. Let's do. I'll do here along with you, because I am also doing what for the maybe second time. I had done this when it was there in the exam. So yeah. So 37 divided by 60 plus we have 7 by 10, then plus 5 by 12, right? It is 26 by 15. Okay, this is what I am getting the answer. Are you all getting that? 26 by 15. Yeah, don't write the decimals here. Lambda square. Now we need to do determinant. Just be very careful while doing the determinant. That is M11. Delete first row, first column. So 7 5s are 35. 35 over 120 minus plus 5. Yeah, that is 1 by 60. This is M11. What about M22? M22 is delete second row, second column. Oh my god. Yeah, doesn't matter. 37 into 5, right? It doesn't matter. Let us do that. 37 times 5 is 185. 185 over 720, right? Minus 17 over 720. This is M22. And M33, could you calculate M33? 7 into this, 37 into 7. Okay, so 259 divided by 600 minus 17 over 300. Okay, times this is lambda. And what about the determinant? Can you tell me the determinant of this matrix? Could you please tell me the determinant of this matrix? Just put the fractional values in your calculator, you will be able to get that. Could you please tell me the determinant if anyone on the other end is calculating? Yeah, anyone of you has got the determinant? Do you get the determinant? Let me also calculate the determinant here. Yeah. I'll calculate the determinant. You let me know if you have got the answer. Yeah. I'll just put a mod. Any one of you has got the determinant of this? Let me know. I'll feed the matrix here. It is 3 by 20 is the determinant for this. Okay, so we'll do this. 3 by 20 equals to 0. Okay, so now let us simplify this. Lambda cube minus 26 over 15 lambda square. Yeah, 3 by 20 is 0.15, right? 0.15, yeah, 3 by 20, correct. Now could you please let me know what happens to this one, these fractions? Have you calculated them? If you calculate them, then you will get them, yeah, 35 divided by 120, right, and added with yeah, so you add that to 1 over 60. Yeah, you add that to 1 over 60. So you have 37 over 120. What about this one? right? That's 17 times, I think 17 times 720, is it? Just check here. 37, yeah, 17 times 720, 17 over 720, yeah. So yeah, that will be 185 minus 17. You got there with this one 2. So you have 168 over 168 over 720. And what about this one? It is 259 minus 34. 259 minus 34 is 225 over 600. Okay, times lambda minus 3 over 20. Could you solve this and let me know what is the characteristic equation? Final answer is 3 by 8. Is it the total addition that you have told me for that? Is it 3 by 8? In Tanishka is there online, and is it 3 by 8 for the final output over there? I'll be yeah, this is slightly different happening. No, 3 by 8 is then for, yeah, 11 by 12 is what you get. Yeah, so lambda cube minus 26 by 15 lambda square plus 11 by 12 lambda minus, yeah, minus 3 over 20 is equals to 0. This is what you will be getting. Can you calculate the eigenvalues for this? You will get some answer. I'll also calculate here. I guess it will be 9 and something like that. 1, 9. I remember some calculations. Let me know what do you get. (26 by 15). Yeah, great. So you have got some eigenvalues which are 9 by 10. Lambda 1 is 9 by 10. Lambda 2 is half. Wow. And lambda 3 is 1 by 3. Such nice eigenvalues. See, this is what I feel. Calculator है तो सब कमाल हो सकता है. तो इतना अच्छा आइगन वैल्यूज आया है. अब आइगन वेक्टर पे देखो, अभी देख लो, because your eigen values are distinct. See, the question paper setter is very smart. Okay, he has he or she has told that show that the matrix A is diagonalizable. So diagonalizable तो यहाँ पर ही हो गया ना, आइगन वैल्यू डिस्टिंक्ट है तो डायगोनलाइजेबल, तो टेंशन ही नहीं. तो आपका एक और एक मार्क यहीं पे आ जाता है. सिंस आइगन वैल्यूज are distinct, matrix A is diagonalizable. इसमें कोई टेंशन वाली बात ही नहीं है. यहाँ पे हो गया. अब आता है आइगन वेक्टर ढूंढने का बारी। ये थोड़ा ट्रिकी है, पर देखो ट्रिक कैसे काम करेगी, बहुत तेज़ी से काम करेगी ट्रिक भी। आपको हम बताते हैं, टेंशन नहीं करना है ज़्यादा, इजी है। कंसिडर फॉर lambda 1 equal to 9 by 10, we have a minus lambda 1 I, capital X equals to 0, right? So what you can do now, from the diagonal entries start subtracting 9 by 10. I'll tell you what to do. Kramer's rule will be very helpful now. So from the diagonal entries, when you subtract 9 by 10, what do we get? Let us see over here. Yeah, from the diagonal entries, we'll subtract 9 by 10. So here we will have minus 9 by 10. You have in the numerator, you have 17 by 60, 17 by 60, the first row, okay? Then it becomes this. And when you subtract 9 by 10 from here, that is minus 2 by 10, right? Because at the center there is 7 by 10. So here it is 1 by 5, and then next row is how much? Just a minute. Yeah, here it is 1 by 5. What about the last one? 9 by 10 when you subtract? Here you get 1 by 12. What about this one? Here you have minus 1 by 12, and 5 by 12 when you subtract here, you get minus of we were subtracting 9 by 10, right? 9 by 10. You get 29 by 60, minus 29 by 60. That is what you get. So now we have to take two rows such that the whole thing comes for the eigenvector, right? x1, x1, x2, x3, and 0, 0, 0. This is what is there. Now see, obviously when you are doing such a question in exam, frustration building up is very natural, because numbers are so tricky, and you know your brain is already half dead at this time कि अरे नंबर इतना डेंजर आ गया, एक तो एग्जाम में धड़ाम दे के बॉम्ब फूटेगा, इतना मतलब क्वेश्चन अच्छा है, खाली if you keep your head cool and do this, it is very simple. Now see what is going to happen. This is 2 by 10 is minus 1, minus 2 by 10 is basically minus 1 by 5, okay? So we will consider that. Now here x1, what you have to write below x1 here, x2, and what you have to write below x3. थोड़ा सा दिमाग लगा के काम करेंगे ना तो आराम से आंसर आता है. See what will come here, it is 17 by 60, right? Below x1 17 by 60, 17 by 60, minus 1 by 5 and 1 by 5. The next one 17 minus how much is it? 17 by 60, 1 by 5, then you have deleted that row, and 17 by 60, 1 by 5, right? What happens here in the third row? You get this minus 17 17 by 60, 17 by 60. Here there is 1 by 5 and minus 1 by 5. Correct? Can you see almost things are very easy? Hi, hello, 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 someone is there, and so hello to everybody those who join in between. अभी ये बहुत मज़ेदार प्रॉब्लम चालू है, तो आप लोग ध्यान से इसको पढ़ना. ओके अभी देखो, इतना ज़्यादा सॉल्विंग करने का दिमाग नहीं लगाने का. अगर करते हो कैलसी है तो कर सकते हैं, पर दिमाग मत लगाओ. मेरा तो कहना इतना ज़्यादा इतना कुछ है नहीं इसमें. फटाफट सॉल्व होता है ये क्वेश्चन. डिटर्मिनेंट है ना. डिटर्मिनेंट व्हेन यू कैलकुलेट, what happens is you calculate the determinant, doesn't matter also. If you see this very carefully, it's going to cancel, the numbers are going to cancel each other quickly. See this, x1 when you multiply, I'm not going to multiply, don't land up doing all that. Minus minus, this is plus 17 by 60 into 1 by 5. Okay, minus x2 over here, minus 17 by 60, 1 by 5, minus sorry, 17 by 60, 1 by 5. What happens over here? Minus 17 by 60, 1 by 5, and minus 17 by 60, 1 by 5. ठीक है? Can you see everywhere same terms, only minus sign is somewhere. So what is there? I can basically write this here. 17 by 60, that can be taken, 17 by 60 into 1 by 5 can be taken common. Nothing more. Determinant में ही कर सकते थे, पर if you don't know the properties, forget about it. You just take it common and cancel it off. So this is 1 plus 1. This is minus x2 over minus 1 minus 1. This is x3 over minus 1 minus 1. So how much is it? x1 over 2 minus x2 over minus 2 x3 over minus 2. What does this mean? This is x1 over 1, x2 over 2, and x3 over x3 over x2 over 1 and x3 over minus 1, I guess. Yeah, minus 1. Your eigenvector is x1 is 1 1 minus 1. This is the eigenvector for lambda 1, which was how much? 9 by 10. So cool. Look at the dangerous eigenvalue and look at the nice decent eigenvector. जोड़ी बराबर जमा है इनका. ओके तो ये थोड़ा हटके प्रॉब्लम है और मस्त क्वेश्चन है. आई रियली अप्रिशिएट दिस क्वेश्चन व्हेन इट केम. करना चाहिए, ऐसा ही क्वेश्चन करो. मज़ेदार क्वेश्चन है. ठीक है, तो आप ये क्वेश्चन कर लीजिए अभी. चलिए, तो अब x2 के लिए लैम्डा 2 कितना निकाले थे? लैम्डा 2 निकाले थे हाफ, और इसमें से अब हम a माइनस लैम्डा 2 i करते हैं तो हमको आंसर मिलेगा. तो a माइनस हाफ करेंगे, तो a माइनस हाफ माने a माइनस हाफ करना है तो कितना मिलेगा मैट्रिक्स के अंदर? It's a good question. I enjoyed this. It is superb. Superb intelligent. गेट वेट में देना है एग्जाम तो मज़ा आ जाएगा ऐसे क्वेश्चन को देख के. तो so how much is this? Half when you subtract. Half is nothing but 30 by 60, right? So 30 by 60 is 7 by 60. Then it is 17 by 60. Here it is 17 by 60. 1 by 5. अभी 7 by 10 में से हाफ सब्ट्रैक्ट करेंगे, मतलब you are basically doing 2 by 10, so it is 1 by 5, right? 7 by 10 minus half, that is 5 by 10, so it is 2 by 5. Yeah, just let me know if any mistake is there. 1 by 12 minus 1 by 12, and 5 by 12, how much does that give you? 5 by 12 is half, right? 5 by 12, and so 6, and this is minus 1 by 12. Okay, so yeah, so this is your vector that you will be getting, x1, x2, x3. Okay, now let it be. We will calculate the eigenvector. So x1 is 17 by 60, 17 by 60, 1 by 5, 1 by 5. x2 is 7 by 60, 1 by 5, 17 by 60, 1 by 5 with minus sign, and x3 when you want to do is 7 by 60, 1 by 5, yeah, and yeah, you can take second row also in this case, because all are going to be linearly independent, right? So never mind on this part, but do carefully. So yeah, when you subtracted that, right? So 30 is 60, yeah, 30, yeah. So this here you get in the first row 17 by 60, 1 by 5. See, again things are collapsing. Can you see the way how quickly they are going to collapse? So the first determinant is 0, so it implies here x1 over 0 minus x2 over, can you see the both these determinants are same? The second determinant, this one and this one, they both are same, so you cancel them. So 1, x3 is also 1, right? It's very interesting question, superb question according to me. It is a very nice question. If you like this question, if you like the solution, hit like in the comment section. I would really appreciate. एकदम जोरदार question है, ऐसा आना, ऐसा question मिलना भी मुश्किल है, and you know, to come someone asking is also a great dare. If you liked it, please hit like button, because ये question देखो इतना बड़ा complicated numbers दिखता है, पर look the way what a decent eigenvector you are getting. Otherwise eigenvector भी कुछ अतरंगी मिलता था. So this is what I appreciate regarding this question. So your eigenvector x2 is 0, 1, 0, minus 1, 1. This will be your eigenvector. समझ में आ रहा है क्या? Are you all guys following over there? Because this is a question which is very tricky, and that's why I had to take it, and so I took up this question. Now let's go for the last eigenvalue. Please let me know in your opinion about it in the comment section. Yeah, 3, 2 people are there. Some are there, some are not there. It did come, so I took it up. कमेंट करके बताओ जल्दी जल्दी क्या लग रहा है. हाउ डू यू फील अबाउट दिस क्वेश्चन? इट्स अ ग्रेट क्वेश्चन. हाँ. So let us see the third case. कोई बोल ही नहीं रहा है. Yeah, question is absolutely good. That's why I took it. So that कर भला हो भला principle of mathematics. But maths can sometimes be tricky. So let's solve this here. For lambda 3, what is lambda 3? We had scored what lambda 3 is 1 by 3. Calculate for 1 by 3. Lambda 3 is 1 by 3. We have a minus 1 by 3 now into. It looks hard. अरे कैलकुलेटर है भाई. मैथ्स में कुछ डिफिकल्ट नहीं होता है when you have calculator. Dude, when you have calculator nothing is difficult. And अभी ट्रिक भी बताया ना. सी ये इतना बड़ा डिटर्मिनेंट कोई कैलकुलेट करेगा, ही इज फूलिंग हिमसेल्फ. यू कांट यू सी ये दिस एंटायर डिटर्मिनेंट, दिस वन एंड दिस वन, दे आर वन एंड द सेम. पहला वाला जीरो आ गया है तो ये तो कैंसल हो गए ना. हार्ड दिखाई देता है पर हार्ड है नहीं. समझ में आ रहा है? क्वेश्चन हार्ड दिखाई दे रहा है, इट इज नॉट हार्ड. और कैलकुलेटर होने के बावजूद भी अगर कोई बोलता है इट्स अ हार्ड क्वेश्चन, देन आई डोंट नो व्हाट टू से. लेट इट बी. ओके, फिर तो अलग ही दुनिया में रह रहे सब लोग. सो 37 by 60 minus 1 by 3, so that is 2 by 10 by 20 by 60, right? So 17 by 60. 2s are 20, we will have to multiply, right? So 17 by 60, see, 17 by 60, 17 by 60, you get this. 1 by 5, 1 by 5 over here minus 1 by 3. Oh, this can this we need to calculate. 7 by 10 and minus 1 by 3. So how much will it be? 7 3s are 21, 21 minus 10 is 11 by 30, and here it is 1 by 5 and 1 by 12, and here it is minus 1 by 12, and 5 by 12 minus 1 by 3 is 4. 1 by 1 by 12, it is 1 by 12. See, nice question is very nice, and look, nice answers coming for eigenvectors. I was scared for eigenvectors. Eigenvalue तो ठीक है, not a big issue. So let us quickly complete this. So x1, hold first two rows, you will get something. Hold second row and third row, something you must get. So what is the first row? First row when you hold is you get 17 by 60, 17 by 60, 11 by 30, 1 by 5, minus x2 divided by 60 by 1 by 17 by 60, 17 by 60 and 1 by 5. Okay, and x3 divided by same, right? 11 17 by 60, 1 by 5, 17 by 60, 11 by 30. Okay, so now see, the middle determinant is 0, right? So you have x1 minus x2 over 0, and what happens, see, can you see that this determinant over here, this one, ये जो determinant है, this determinant and this determinant, what is the difference in them? The rows are the columns are interchanged, right? The columns are reversed. So when the columns are reversed, the determinant sign changes. So if that is 1 but value magnitude is same, the sign is going to change. So what I am going to do is, one of the places I'll just put -1. If I put 1 here, x3 I'll put -1. That's it. So my eigenvector x1 is 1. Eigenvector x1 quantity will be 1, 0. x3 quantity is -1. So my x3 eigenvector is 1, 0, -1. We got 3 eigenvalues. So lambda 1 was 9 by 10. x1 we got a nice eigenvector, a very nice eigenvector. What was that? 1, 1, -1. Nice one. 1, 1, -1. Lambda 2 was half. x2 eigenvector. What was x2 eigenvector for that? 0, 1, -1, right? 0, 1, -1. And lambda 3 is 1 by 3. We got x3 as 1, 0, -1. Okay? Such a nice question. Look at the decency of the question. ये है question. तो आपको, I hope this was all on my side. There is one more type, but maybe for some other, I'll save it for future reference. Some another time we will see that. Okay, yeah, thank you for joining in for this kind of lecture, and I hope you liked it. Please hit like button and let me know what your thoughts are there. I'll wait for few moments, and till the time the whole live setup gets completed and whole things are there. So if you have any doubt, let me know. I would be happy to help you. And कुछ भी है पूछ लीजिए. इतना ही है मेरे पास तो आइगन वैल्यू आइगन वेक्टर के बारे में अभी फ़िलहाल बताने के लिए. और अगर कुछ वेराइटी मिला which is like, you know, can be asked or can be fun to the brain, then we will see in detail about it. Yeah, thank you all for those who joined in, and this was what I had from my side on this. I hope you liked the lecture. All important questions, all tricky questions, many shortcut techniques I told you, and I hope they will be helpful to all of you. Yeah, thank you. Like I see on the other side of the screen, because my main PC on which I'm working is here, and the other one is on the setup. So setup thing is on the other one. So that's how it is. Yeah, thank you all of you for joining in. We will yeah, there are some people tuning in now. Thank you for joining. Please hit like, share it with your friends, share maximum of this, help people to gain fun in this topic, show them how nice this lecture was, and help them to, you know, get involved. Ask them to watch this. It would be great for them also, because the fun in this is calculator helps you to create miracles in this example. And you should know some properties also of those calculations, and keeping the answers in fraction would have helped you. If you convert this question to decimal, you will land up in chaos. You will not solve this, you will give up. Okay. So thoda smart moves is also important in this. Okay, so thank you for joining in. We'll have a cut down now on this lecture, and thank you all for joining in. Bye bye, good night, take care. Yeah, keep here, I'll keep the annotations. Okay, bye bye bye.